We are now looking at an introduction to the property of logarithms part of this section, where we'll be using the properties to condense down a few logarithms to make it into only one logarithm on either both sides or one logarithm in general in order to solve some of these equations. And some important notes that we need to know are, first, the properties themselves. So if you remember these three properties, we had the product property, where if you add two logarithms with the same base, you can combine them to multiplication. And you can kind of see that these, the A and the B here, are in parentheses. And the second one was the quotient rule, where if you subtract two logarithms with the same base, you can combine them into one where you're dividing. And then the power rule is the third and final property we might use, where if you have a coefficient in front of a logarithm right here, you would move that on top of the input, and that would become its full input, in this case, m to the power of p, when p used to be the coefficient. The steps for solving log equations with these properties is that you always make sure to check, do I have the same base with all of these logarithms first? And second, you would need to be able to condense them into one logarithm using these properties, so you have only one logarithm in each side of the equal sign. In some problems, you only have one logarithm total and a number on the other side of the equal sign. We're going to look at some examples and work through them together in the next part of this video coming up right now. We are now looking at some examples of solving logarithm equations using properties. And in each of these four examples, you'll see some different things happening, some different strategies used from the notes we've looked at so far together. So in number one, we are looking at log base 10 of 27 is equal to 3 log base 10 of x. So think about what properties might be used this one. Well, we don't see any adding and subtracting, but we do see a 3 in the front. So that 3 is going to go on top of our x right there. And so we would write everything again as log base 10 of 27 equals log base 10 of x cubed. And now that we have a log of base 10 on both sides with nothing else, well, we can just get rid of these two logarithms. And we now know that 27 is equal to x cubed. If you're not sure how to do that, you can always use your calculator. So let's kind of pull that up real quick to practice. So if we want to get the cube root of 27, we hit the math button and then scroll down to the cube root and then 27. That means our answer is 3. Now we just need to write that out over here as 3 is equal to x. Number two, if we look at the problem first, take a second to think about what you might do with this one. I see a 2 in front, so that's going to be the power rule again. I also see a plus sign, so that is going to be the product rule. So let's kind of put the 2 in the front on top of the 5 first, rewrite everything, taking it one step at a time. And we didn't do anything to the right side of this equation. Now, because of this plus sign right here, we're going to put these two logarithms that we're adding and then multiply their inputs. So I'm going to multiply 5 squared, or 25, by x inside of one logarithm now. Log base 3 of 25x is equal to log base 3 of 50. And now that we have that, we can just get rid of these two log base 3's and rewrite this as 25x is equal to 50 and x is equal to 2. So in both of those, we figured out that we can make it to a logarithm equaling a logarithm. Now we're looking at two problems where you're going to have it equal to a number instead. So we just want to put together the two logarithms and then solve it using logarithm form to exponential form. So this plus sign means that we're going to have one logarithm where they're being multiplied. 3x is what x times 3 would equal, and that's going to be equal to 3. Now we can just convert this to an exponential form. 3 to the power of 3 equals 3x. And we have 3 cubed equals 3x. 3 cubed is 27. And then divide by 3 means our answer is going to be equal to 9. That leaves our final problem here at the top of our number 4 right there. So now we have two base 2 logarithms that we're subtracting now. That's the difference. When you subtract, that means you have to put them into one logarithm and divide. So let's do that with log base 2. We have x plus 4 being divided by x minus 3, all equal to 3. Now that I've done that, I want to convert this to exponential form. 2 to the third power is equal to this fraction. And I can write that out. 2 cubed equals x plus 4 over x minus 3. Put some parentheses in our fraction. Now we know 2 cubed is 8, but we also want to kind of rewrite this in terms of fractions on both sides. So we're going to write it as 8 over 1, which is the same thing as 8, and also the same thing as 2 cubed, equal to the fraction we already had on the right side of this equation. And now we can cross multiply. We're going to do 8 times that fraction, 1 times that one, and then they're going to be equal to each other after we do that. So 8 times x minus 3 would be 8x minus 24. And then x plus 4 would be 1 times that and wouldn't change. Once you've put all of this together and solved it out, turns out that x is going to be equal to 4. Now that finishes up that example right there with x being equal to 4 for number 4. An important reminder for all logarithm equations is that you can't take a logarithm of something negative. So if you ever get an x value as an answer and you put it into any logarithm where it's taking the log base whatever of a negative number, that can't happen. So up here at the top and write a little note for everybody. So log base b of a negative means extraneous answer. Means an answer that does not work. That is it for solving logarithm equations using properties for this video.